Hey everyone, Math 103, working on section 3.3 today, general equations. Got a warm up? Please start with that. So the first one, we're subtracting a fraction, so we're going to add this fraction to both sides. We're going to add together 5, 6, and 3/8 to get the right side. Common denominator here will be 24. 20/24 is what 5/6 becomes. 3/8 becomes 9/24. So we get x equals 29/24. For number 2, now we've got a coefficient on the x, so we need to multiply by its reciprocal. So that'll be -3/2. Everything cancels on the left. We get x equals 10 divided by 2 is 5, times 3 is 15, so we get -15. Now last time, we worked on equations that used either the addition property or the multiplication property to solve. Now we're going to look at equations that require both properties. So, which one do we use first? Well, the answer is order of operations, except we're going to do them in reverse. When we're evaluating expressions, the last thing we would ever want to do is add or subtract. It's always the final step was addition and subtraction. Now, we want to start with addition and subtraction, and then move on to things like multiplication. For example, we got 2/7 x minus 1 equals 3. Now, if we were to start this with multiplication, we'd have to multiply every term by whatever we're multiplying by. And that's going to be more work than if we simplify it down first and then do the multiplication. So I'm going to start with addition to get rid of this 1. Plus 1 on both sides. Now that we've gotten rid of the 1, now we've got an equation just like the ones we were working on last time. All we have to do is multiply by the reciprocal of this. 7/2 on both sides. The 7's cancel, the 2's cancel, leaving just x on the left. 4 divided by 2 is 2, times 7 is 14, so x is 14. Your turn, number 1. Five thirds x plus 4 equals 14. So start with addition subtraction. We've got this 4 added on to the x term, so we're going to get rid of that first. Subtract 4 from each side of the equation. That just leaves 5 thirds x on the left, and on the right, 14 minus 4 is 10. Now we can multiply by the reciprocal of the coefficient. Ten divided by 5 is 2, times 3 is 6, so x equals 6. Now it gets a little trickier when we're subtracting the x term. So we've got this x term, the negative is on the 4x. It has nothing to do with the 7. So the 7 is positive, so we want to get rid of that first. Subtract the 7 from both sides. Now these go away, this term comes down. What I see a lot of students doing is forgetting to bring the negative down with it. That is negative 4x equals oops, 24. Now we divide both sides by -4. We get x equals -6. Your turn, number 2. So we'll start with addition subtraction. Get rid of the -1 first by adding 1 to both sides. Now I'll bring down -3x. That equals 12. Divide by -3 on both sides. Get rid of that coefficient. We get x equals -4. Now we're going to look at some equations that have more than one fraction. Best way to solve these is just get rid of the fractions all at once. I see a lot of students try to work with a fraction and then having to do multiple operations with fractions, including addition, subtraction, multiplication, division. And by the time they get to the end, it's a big mess with a bunch of mistakes. Fractions are hard to work with. Much harder than whole numbers. So what we're going to do is get rid of them and turn it into an equation with just whole numbers. So with an equation like this, first thing we need to do is find the least common multiple of all the denominators. 4, 5, and 10. So that least common multiple for those three numbers is 20. So we'll multiply the entire equation by 20. Make sure you put parentheses around the whole thing, or brackets, or whatever you want to use. And the number goes on the outside. Now take that number, divide by the denominator. 20 divided by 4 is 5, and then multiply by the numerator. 5 times 1 is 5. So that gives us 5x for the first one. 20 divided by 5 is 4, times 2 is 8. So you get 8 there. And then over here, 20 divided by 10 is 2, times 9 is 18. So with one multiplication, we get rid of all of those fractions. Keep in mind, you have to multiply by every term. Terms are the things that are separated by plus, minus, or equals. So here we have 3 terms, so we did 3 multiplications. And now we'll solve this one just like we did the others. Start with addition, subtraction. We're going to get rid of that positive 8 by subtracting 8 from each side. Giving 5x on one side, 18 minus 8 is 10. Now when doing this, make sure you put like terms underneath like terms. Keep things lined up in columns like that. Never put minus 8 underneath 5x, because those are not like terms and we cannot add or subtract those. Divide both sides by 5 and we get x equals 2. Your turn, number 3. So with this one, we're going to look for the least common multiple of 3, 5, and 15. And that is 15. So if you multiply this entire equation by 15, it'll get rid of all the fractions. Now, if ever you multiply and your fractions are not eliminated, that means you've made a mistake in the calculation of the LCM or in your multiplication. Something has gone wrong along the way. All right, divide by the denominators. 15 divided by 3, that's 5. Multiply by the numerator, times 2, we get 10. So that's 10x. Minus, make sure you keep track of your signs. 15 divided by 5 is 3, times 8 is 24. Equals 15 divided by 15, those cancel, leaving just the numerator, 26. Now I'm going to add 24 to each side. We'll do the opposite of what's here. We have subtraction, so we'll do addition. And what I like to do is I like to keep things in their columns. Helps keep things organized and also prevents the mistakes of adding together things that are not like terms. So the x term is going to come straight down. The equal sign comes straight down. 26 plus 24 is 50. Divide both sides by 10 and we get x equals 5. All right, another one of these. It's good to practice these with all these fractions. Got 1/4 minus 3/8 x equals 11/12. Now we need a common multiple of 4, 8, and 12, and that'll be 24. So multiply this whole equation by 24. 24 divided by 4 is 6, times 1 is 6. 24 divided by 8 is 3, times 3 is 9, so it's minus 9x. And over here, 24 divided by 12 is 2, times 11 is 22. All right, now I need to get x by itself. So we'll start with addition subtraction. So I want to get rid of that 6 first. Bring down the 9x term. Make sure you bring down the sign because the sign is attached to what follows it. So this negative is attached to 9x. You have to bring that down with it. 22 minus 6, that is 16. Divide it out, and we get x equals negative 16/9. Your turn, number 4. Least common multiple of 3, 2, and 4 is 12. So multiply that whole equation by 12. We have 3 terms here. Everything's separated by plus, minus, or equals. So we got 3 of those. We'll do 3 multiplications. 12 divided by 3 is 4, times 2 is 8. 12 divided by 2 is 6, times 1 is 6. And 12 divided by 4 is 3, times 3 is 9. So there's the equation after eliminating all those fractions. Now I'll subtract 8 from each side. Bring down negative 6x. That equals 1. We'll divide by negative 6 on each side, and we get x equals negative 1/6. Now we may need to do a little bit of simplifying first to get the equation into the forms that we've seen so far today. And if you see like terms on either side of the equation, always start by combining like terms. Should be the first thing you look for is ways to simplify the equation. So we got 4x minus 15 plus 2x equals 9. Looking at the left side of this equation, we've got two terms where the x is the variable. Those are like terms, so we'll combine those together. 4x plus 2x is 6x. We got 6x minus 15 equals 9. Now it looks like the other ones we've solved before. So we want to get rid of the 15 first, so we can get the x by itself. So we'll add 15 to both sides. So we got 6x equals 24. And x equals 4. Your turn, number 5. We got 8x minus 22 plus 5x equals 4. Getting two x terms, we're going to combine those together to get 13x. 13x minus 22 equals 4. Now we can add 22 to both sides. $13x equals 26. Divide by the coefficient on the x. Divide by 13. X equals 2. Next example. Be real careful with signs on this one. 2x minus 5x, that's negative 3x. So we have negative 3x minus 8 equals 1 for the next step. Now we want to get rid of this negative 8, so I'm going to add 8 to both sides. This stays negative, minus 3x equals 9. Divide by the coefficient, so we can divide by negative 3. Make sure you divide by the negative if it has one. Now we got a positive divided by negative, so that gives us negative 3 for the answer. Your turn, number 6. $4x plus 18 minus 7x equals 6. Combine the x terms, 4x minus 7x, that's negative 3x, plus 18 equals 6. All right, now we're going to get rid of that 18, so we're going to subtract that since it's being added. Oops. So negative 3x here equals 6 minus 18 is negative 12. Now I'll divide by the coefficient, the negative 3. X equals 4. So now we're going to look at some applications that use equations like the ones we've seen so far in this lesson. The first one is the basic markup equation. So when stores sell things, they buy things at a certain cost, and they add what's known as the markup to that cost. When you add those two things together, you get the selling price. So here's the equation we're going to be using, where S is the selling price, C is the cost, and R is the markup rate. And that rate is a percent of the cost written as a decimal. So for example, we got a store that pays $2,200 for all-terrain vehicles and sells them for $2,500. And we're going to find the markup rate. So we're going to plug in what we know and find what we don't. We know the sales price, and that is $2,500. We know the cost, that's $2,200. Plus 2,200 times R. And we can flip those around because multiplication is commutative, or it doesn't matter. And traditionally we write the variable after the constant. Now we can solve this equation for R. So I'm going to start by subtracting this constant here, 2,200. So that gives us 300 equals 2200R. Now all we have to do is divide by the coefficient on the variable, 2200. And that gives us R equals 0.136. Now we'll convert this to a percent by moving the decimal 2 places to the right. And that is 13.6%. So the store buys them for 2,200 and then adds 13% to the price, and that's the selling price of 2,500. Your turn, number 7. Company buys solar panels for $182 and sells them for $256. Find the markup rate. So the sales price is $256. Cost is $182, so we get $182 plus $182R. So we'll start just like the other one by subtracting the constant. So basically we're combining like terms here. And we get 74 on the left equals 182R. Divided by the coefficient. And R equals 0.4065. I'll move the decimal 2 to the right. So it's 40.65%, and if you want, you can round that to 40.7%. Next up is an example from nutrition, and we're going to be able to calculate the number of calories in a meal if we know the grams of fat, carbohydrate, and protein. Or if we already know the calories, we can find the grams of one of those three. So the equation we'll be using is calories equals (9F plus 4P plus 4C). Because there's 9 calories in each gram of fat, 4 calories in each gram of protein, and 4 calories in each gram of carbohydrate. In the first example, we want to find the number of grams of fat in a serving of food containing 163.2 calories. So we'll plug in 163.2 for C. We're solving for F, so we'll leave that as 9F. We're looking for the grams of fat. We're given the grams of protein, that is 5.4, so we've got 4 times 5.4 plus 18.3 grams of carbohydrate, so 4 times 18.3. So we can start off by evaluating these on the end here. 163.2 equals 9F. Plus, when we multiply those out, we get 21.6 and 73.2. And we'll add those two together. We're combining like terms whenever possible on one side of the equation. Adding those together, we get 94.8. Then subtract the constant from each side. That gives us 68.4 equals 9F. Finally, we'll divide by the coefficient on F. And we get F equals 7.6. So you write these out, just make sure you tell what the number means. We want the units, grams, and what we're talking about, grams of fat. Your turn, number 8. We're going to find the number of grams of carbohydrate in a serving of food containing 228 calories, 11.6 grams of fat, and 3.7 grams of protein. So we're looking for the number of grams of carbohydrate, so that's going to stay C. Plug it in 3.7 grams of protein and 11.6 grams of carbohydrate, and we know that the meal has a total of 228 calories, so that goes in for C. All right, now just like the other one, you can start by multiplying here. So 228 equals 104.4 plus 14.8. And leave that plus 4C on the end. Now we can combine these two. So it's 119.2 plus 4C. All right, now we'll subtract the constant. Oops, that turned into a plus. Equals minus 119.2 from each side. That gives us 108.8 on the left and 4C on the right. And finally, just divide by the coefficient on C. So we're dividing by 4, and we get C equals 27.2. There are 27.2 grams of carbs. All right, next up, we're going to look at a formula used to judge the size of trees. Looking at what's the biggest tree in a competition. So each tree is given a number of points based on this formula. We got P equals C plus H plus 1/4 S. Where C is the circumference of the trunk in inches, H is the height of the tree in feet, and S is the crown width, which is the widest part of the tree, how wide it is at the widest part, and that is S. So the first tree we're going to look at has a height of 120 feet, average crown spread of 48 feet, and scores 367 points. So we got 367 points on the left equals circumference, we don't know, that's what we're solving for, height, 120, and 1/4 times crown spread, average crown spread, which is 48. So we can start over here, multiply these two together. 1/4 times 48 is 12. And we'll combine like terms over here. So we get 367 equals C plus 132. And now we can subtract the constant, minus 132 on each side. And we get C equals 235. So the circumference is 235 inches of that tree. Your turn, number 9. Your tree scores 356 points, the height of 156 feet, and a circumference of 186 inches. We're going to find the average crown spread. So there's our formula. We got 356 points. Circumference is 186. The height is 156. And we're solving for the crown spread, so S will stay in the equation. We'll start by combining like terms here. Add those together to get 342, and keep the 1/4 S on the end there. We'll subtract 342 from each side. So that's 14 equals 1/4 S. Now we'll multiply by the reciprocal of the coefficient. So the reciprocal of 1/4 is 4. That gives us S equals 56. So the average crown spread is 56 feet. Next up, we have an example from physics about freely falling motion. So this is objects that are either thrown or dropped. Gravity takes them down, and we're going to ignore air resistance. So S is the distance fallen. T is the time that it's falling. And V is the initial velocity. So if it is initial velocity, maybe you're taking a ball or something and throwing it downwards. We want the initial velocity of an object that falls 118.6 feet in 1.4 seconds. So the distance, again, is S, so 118.6 goes in for S. Now for every instance of T, we're going to put in 1.4. So 16 times 1.4 squared plus 1.4 V. And we're solving for the initial velocity, so we're going to keep V in the equation. Now first thing I want to do is figure out what the 16 times 1.4 squared is. You can just put that in your calculator, get it all at once. And that gives us 31.36. Plus 1.4 V. All right. Using reverse order of operations, I'll subtract. That gives us 87.24 on the left equals 1.4 V. I'll divide. And V equals 62.3. The initial velocity is 62.3. And velocity is distance over time for the units. So our distances are measured in feet, and time is in seconds. So 62.3 feet per second. Your turn, number 10. Find the initial velocity of an object that falls 168 feet in 3.4 seconds. So we're given 168 feet for the distance and 3.4 seconds for the time. So 16 times 3.4 squared plus 3.4 V. We multiply this out, we're going to get 184.96. And subtracting the constant from each side. So we got a negative value up here. It may seem strange to get a negative value, but It does happen in physics, and we'll see why in a moment. So dividing by 3.4, it gives us a velocity of negative 4.988, and we'll just say that's about negative 5. So we've got initial velocity is negative 5 feet per second. So what does the negative mean? Well, if we're going with gravity, the initial velocity is positive. If we're going against gravity, the initial velocity is negative. So this is like tossing the object upward first. It's going to go up and then eventually come down. Now we've got two more, your turns. First is an example from Anthropology, where we can figure out either the size of the humerus or the height of the primate if we know one or the other. And then an example from car safety talking about black ice. So go ahead and work on those. So first example from Anthropology, we've got the height of a primate is related to the length of the humerus by the equation h equals 1.2L plus 27.8. And in this example, we're given the height at 54.6 inches. So that's going to go in for h. 54.6 equals 1.2L plus 27.8. Right now, we'll subtract this constant from each side. 27.8. So that gives us 26.8 equals 1.2L. Now we can divide by 1.2 on each side. And we get L equals 22.3. And that is in inches. The length of the humerus is 22.3 inches. Now, the black ice problem. So we're going to assume that the car is traveling at 30 miles per hour, and the relationship between the temperature in Celsius degrees and the distance the car slides is given by this equation. Now in this example, we want to figure out how far the car is going to slide when the outside temperature is 5 degrees Celsius. So put in 5 for C equals 1/4 D minus 45. And we can add the constant to both sides, plus 45. We've got 50 equals 1/4 D. And we'll multiply by the reciprocal of 1/4, which is 4. 4 on both sides. And we get D equals 200. So that car is going to slide 200 feet. So drive carefully, people. That's it for today.